everyone, welcome to my channel Chemistry by Nitish Sharma. Guys, today's topic is determine the point group C2 point group for this molecule. So you clearly visible from the picture, this is the molecule which name is 1,4-dibromo 2,5-dimethyl benzene, as you clearly observe through the model and also observe through the picture. Okay guys, now start to understand the point group involved in this molecule. This is the bromine and this is another bromine, and this is methyl, this is methyl. So these two methyl are this 6 atom of benzene ring and both bromine atom, and these two hydrogen atom which is bonded with the benzene ring all are lying in the same plane, but this methyl does not lie in the plane, so this is not lying in the plane. Okay guys, so the 6 carbon atom of benzene and 2 bromine atom and 2 hydrogen atom of benzene which attached to the benzene are lying in the same plane, but this methyl group does not lie in this plane. Okay guys, now we clearly understand. First of all, we check the number of symmetry operation along this molecule. So if we check operations, that is C4 C axis between this molecule. Okay guys, this is, if we consider this axis, this is C2 C axis, and we can clearly observe that this bromine atom rotate through angle 180-degree through this axis. It can cover up here, so this methyl group replace along this axis with the angle of 180-degree get here, so we can obtain equivalent configuration, and this hydrogen atom replaced by this hydrogen atom. So there is existence of theta 180-degree, because through 180-degree rotation we can obtain equivalent configuration. So C2 axis lie between this benzene molecule. Okay guys, if we rotate 360 angle, then we also get identical configuration for this molecule. If we check along this axis whether the C2 axis exists or not, this methyl group replace another direction through this axis get here, and this hydrogen atom get here. So this does not get equivalent configuration, because atom cannot form same configuration along this axis. If we check along this axis, then this bromine atom replace this bromine atom, this is equivalent, but the methyl group and hydrogen atom does not equivalent. Okay guys, if we rotate this is not equivalent formation. So methyl group here, and also in this also methyl group here, so we does not get equivalent configuration, so does not exist this axis along this molecule. So there is axis exist only in between this center of the benzene ring. Okay guys, so you can clearly understand that there is not existence, there is only one C2 axis present in this molecule, and not other axis does not present in this molecule. Now we check plane of symmetry along this axis. Either we get same configuration or not. Either it's reflects same configuration or not. This methyl group reflect through this plane here. So this is not equivalent configuration. So this axis does not contain vertical plane. Check along this axis. If we get same configuration, both the bromine atom reflect each other through this axis, then we get equivalent configuration. But the methyl group and hydrogen group, this is the methyl group, and the reflect through this plane we can appear here. So we does not get equivalent configuration. So guys, this axis also does not exist in this molecule. Now check horizontally. If we check horizontally, then you can see that all the atom are equally reflect. Okay guys, all the atom equally reflect through this plane, as you clearly see. but this methyl group and this methyl group doesn't replace. So you can clearly see with this mirror. So guys, if we check center of inversion is exist or not, so this consider here center, and we can check above bromine atom and below bromine atom. Let's consider here is the center of this, above and below is bromine atom, and we go through this, we can obtain hydrogen and as well as this hydrogen, and we get along this carbon atom, so we can obtain methyl and methyl group. Both are methyl group appears if we consider here center of this molecule. So I is exist in this molecule. Center of inversion exists in this molecule. Okay guys, you can clearly observe the symmetry operations are E, C1, C2 and center of inversion. So there is exists S2 because S2 equivalent to I. Okay, okay guys, there is no sigma v plane, no vertical plane, no dihedral plane, no horizontal plane. Okay guys, so if this molecule exists in this C2 axis, it means the point group belongs to C. Then the possibility of point group in the C are Cn, CnH, CnV, C infinity V. But the molecule is not linear, so C infinity V does not exist in the molecule. Here we can see that center of inversion and S2 so not CNX and not horizontal, not vertical, because horizontal and vertical plane does not exist in the molecule, so there is presence of only Cn. Okay guys, so C2 is the point group for this molecule. I hope guys you will clearly understand with this diagram. Okay guys, if you like it, then like it, share it and subscribe my channel. Thank you guys for watching.